The close-up live shooting of U.S. space shuttle launches has fascinated millions, offering a detailed look at the complexity of spaceflight. Such footage provides an unparalleled opportunity to understand the shuttle's structure, the launch sequence, and the forces at play. Space Shuttle design. 1. Orbiter. The crew cabin, payload bay, and wings make it the reusable part of the shuttle. 2. External tank ET. The large orange tank holds liquid hydrogen and liquid oxygen to power the shuttle's 3 main engines during ascent. 3. Solid rocket boosters SRBS. 2 white rockets attached to the external tank provide most of the initial thrust at launch. T0. Ignition and liftoff. The shuttle's 3 liquid-fueled main engines ignite about 6 seconds before liftoff. Cameras capture the bright blue flames of superheated exhaust as hydrogen and oxygen combust. Simultaneously, the 2 solid rocket boosters SRBS are fired, generating 7 million pounds of thrust. You see flames, smoke, and a deafening roar as the vehicle leaves the ground. To avoid fire damage, flame trenches and watt. 2. Initial ascent and roll maneuver. The shuttle pitches and rolls to align with its launch trajectory. Cameras mounted nearby capture the orange glow of the SRBS and white vapor trails created as the shuttle soars upward. 3. Solid rocket booster SRB separation. At about 45 kilometers altitude and 2 minutes after launch, the SRBS separate, captured by cameras mounted on the boosters themselves. You can see these boosters parachuting back into the ocean for recovery. 4. External tank ET separation. Around 8 minutes into flight, the ET detaches once the main engines cut off. Cameras aboard the orbiter show the tank falling back toward Earth, where it eventually burns up in the atmosphere. 5. Orbital insertion. The orbiter fires small thrusters to fine-tune its orbit. Close-up footage of the payload bay doors opening marks the shuttle's readiness for mission operations, such as deploying satellites or conducting experiments. How the shuttle works. The Space Shuttle program relied on unique engineering innovations for launch, re-entry, and landing. Launch propulsion 3 main engines, fueled by the external tank, generate over 1.2 million pounds of thrust each. The SRBS provide initial power but burn out first, detaching once their fuel is depleted. Reusability. The orbiter glides back to Earth, landing on a runway like an airplane. The SRBS are retrieved and reused after refurbishment. The external tank, however, was not reusable and burned up in Earth's atmosphere. Close-up cameras and equipment. High-speed tracking cameras from ignition to SRB separation. Specialized heat-resistant cameras on board the orbiter and boosters provide real-time visuals of the journey from Earth's surface into orbit. Microphone arrays and shock sensors allow scientists to study the immense sound waves and vibrations during the launch.